Welcome back to more Fun with Finance. I'm Dr. William Elliott, coming to you from my studio in beautiful uptown Shaker Heights. So this chapter, chapter 6, is on kind of follow on to chapter 5. So we started there by talking about time value of money, moving money from the present into the future and from the future back to the present, and how we go about that. There we looked at predominantly lump sums for one period and then lump sums for multiple periods. So I made this announcement during the lecture for that chapter, but I'm going to say this again at the beginning of this chapter. If you didn't understand something in chapter 5, make sure you get in touch with me so that you've got a good sound understanding of moving money to the forward, to the future and back to the present, and how that's done. When we move it into the future, we are compounding it or grossing it up. Both are synonyms. In other words, the values get bigger as we move into the future. Think of, putting it into a savings account. You put $1 in today, and 2 years later, you come back out with $1.10. When we discount it, when we bring things back from the future to the present, we're discounting it, and the amounts get smaller. In other words, $1 in the future is worth less today because of time value of money, basically because of things like inflation and interest rates and what we demand as a group in order to give up our ability to purchase now and actually purchase something later. So, all right, if you understood all of that material, or if you got some additional help, now we're ready to jump into more complicated transactions with regard to time value of money. Here we're going to have multiple cash flows over multiple periods, and sometimes those cash flows are going to be the same, sometimes they're going to be different. Sometimes we'll be moving the money into the future, other times we'll be bringing it back to the present. And so basically it builds off of 5. The basic techniques are no different, no more complicated than what we saw in 5. It's just that we have a lot more numbers. And again, I mentioned timelines. Now, in this chapter, your authors do use timelines, and so those show up in the slides and in the chapters. But make sure you use those, because without those, you're going to run into difficulties. You won't know when the particular cash flow is timed. The other thing that you'll have to learn is how the financial calculator, the BA2 Plus, how it treats the cash flows when we're using the N, the I, the PV, the PMT, and the FV keys. So we'll talk a little bit more about that in this chapter. And then finally, I'm going to break this video up into 2 pieces. So we'll get about midway through the chapter, and then I'll finish it up with a second video just to kind of keep these things at about an hour-ish. But there's a whole lot of material in this chapter, so be ready. And don't give up. It's not as complicated as it might initially look, though I know when I first tried to learn this, it was kind of baffling to begin with. But once you go over it a few times, then it starts to make a little more sense. So if you don't get it the first time around, don't worry. That's not the end of the world. Just keep practicing it. It's like anything else that you're trying to learn. Practice, practice, practice. All right. With that, let's get to the slides. I'm going to move out of the way here, and we'll get going on this. So outline, we're going to look at present and future values with multiple cash flows. We're going to be valuing a series of level cash flows where the cash flow is the same every period. Those are called annuities, and if there's no end to that, they're actually called perpetuities. Then we're going to compare different types of rates. We'll talk a little bit about APR, which is annual percentage rate, and we'll talk a little bit about EAR, which is effective annual rate. And it's very important. That actually will be the second lecture. Same thing with loan types and amortization, things of that nature. So here we go. Let's start off with this example here. We have, let me grab my pencil. I'm going to change the color to blue. And suppose we deposit $100 today in an account that is paying 8%. interest, and here we're assuming annual compounding. Now, we're going to talk a lot about compounding in this chapter, and we're going to start off with annual, but we're going to see that we can change that to any periodicity. We can have quarterly, we can have monthly, weekly, daily. Second by second, we can have what's known as continuous time compounding. In other words, instantaneous. It's always compounding. The reason compounding is important is that what that basically means is that you're going to get interest on what you earned in the prior period, and that's going to be added to your principal for the next period. So when we talk about compounding, it means that now you're going to be able to get interest on that interest. We saw that in the last chapter, but here I think it'll become even more apparent. That's really what makes investing so powerful, especially if you're talking about investing over long periods of time. All right, so we have this $100. We deposit it today, and in one more year, we're going to deposit another $100. So now we have two cash flows here. And the question that we're trying to answer is, how much will we have at the end of 2 years? So let's look at this on a timeline first. And this timeline right down here, timeline A, that's not a very good color, is it? So let's try this. Timeline A. And here are the cash flows. So here's the first one. That happens now at time 0. All right. And then we deposit another $100 here at time 1. And we're looking for the value right here at time 2. So we're going to be moving this first cash flow. We're going to be moving it 2 years into the future. And then we're going to be moving the second cash flow just 1 period into the future. And we're going to add those together. And that's going to give us the future value of those two cash flows earning 8% per year. There are multiple ways we can approach this, multiple ways we can get this question answered. And the text is going to show you several of those techniques. This first one is essentially we're going to work period by period, and we're going to look at every cash flow. And we're just going to move it to the next period, and then we're going to add any other additional cash flows that occur at that next period. And then we're going to move all of that to the period after that, and so forth. Another way to do it is to simply deal with each cash flow over the entire range of time and then add those values together. We'll end up with the exact same amount no matter which technique we use. So this one here, what they're doing is they're looking at all the cash flows that occur in each particular period. So first, let's start with that $100. And I'm going to zoom in a little bit so you can see this a little more clearly. And it's earning 8%, so there's our 8%. And that means that in 1 year, we'll have $108. Now, at that same time, we're going to be depositing an additional $100. That's a brand new deposit to the account. So at the beginning of year 2, or end of year 1, we'll have $208. And that $208 is going to earn 8% over the next year. So 208 times 1.08, that is, just think of that as 1 plus R. R is our interest rate. And so we'll end up with $224.64. All right? Does that make sense? Now, if you click here, the slide that shows an alternative method. So that alternative method is we're going to take this $100 right here, and we're going to move it 2 years out and record that value. Then we're going to take the next $100 right here. We're going to move it 1 year out, and we're going to record that value, and then we're going to add the two together. We're still going to end up with $224.64. Let's just take a quick peek at that. And my link is not working here. All right. There we go. Okay. So here we have, let's do the timeline. Thought this slide had a timeline on it, but apparently not. And let me get back to a pencil so it doesn't get quite so messed up looking. And here's time 0, here's time 1, here's time 2. We've got that $100 that occurs right here. And so the first thing that we're going to do is calculate what is the value of that $100 as we move it from today out to time 1 and then out to time 2. So that would be 1 plus r raised to the second power, because we've got 2 periods, times $100. So we have 1.08 raised to the second power times 100. And let me get the calculator out. And so I have 1.08, and we're going to raise, well, let me just do the multiplication, right? Times 1.08. That's going to give us 1.1664. And we're going to multiply that by $100. And obviously that's going to give us $116.64. 116.64. Okay, now we record that and save that. The next thing we're going to do is look at the next cash flow. That's the $100 that we add in 1 year. And we're only going to move that out 1 year because everything lines up here at year 2. And obviously that's also earning the same 8% to the first power times 100. Well, the math there is easy, 108 and 0 pennies. So now let's add those two together. We get 0.64. We get 224.64. And lo and behold, 224.64 is what we got over here as well. All right. So those are the two techniques. Doesn't really matter which one you do. And by the way, there's actually even a simpler way to do this, and that would be to use the calculator, using some of the TVM what's the word I'm looking for? Using some of the time value of money function keys. So what I could do is I could say, now this is going to be a little more difficult initially, at least for you. So let me go back. Let me grab the timeline again here real quick. So because of the way the calculator functions, and because of the layout of our cash flows, we've got $100 here, we've got another $100 here, and we're actually looking for the value out here. So there's no real easy shortcut to this. I'm actually going to break it into 2 steps here. What I'm first going to do is I'm going to figure out what is the value of a present value of $100 plus a single year of payment at $100. And I'm going to figure out what is the value of that right here. And then I'm going to take that value and move it 1 more year out into the future to answer our ultimate question here. What is the value in 2 years? And we're looking for 224.64. When we get that, we know we'll have the right answer. All right, so let me clear our registers and clear our work. So we're going to start off with, I want 1 year. I'm only going out 1 year for this first calculation. I'm going to have both a present value and a payment. The present value is that first $100. The payment is that second $100. I could do it as a present value and a future value and zero out the payment. Either way is going to get me to the same result. Let's start with the first method though. So we have 100 present value, and I need to put in I, that's 8%. And then I'm going to make my payment 100. Because what I'm going to do is I'm going to compute the future value, and I get 208. Okay, so think about it back to when we did the period by period with all the cash flows. So that $100 that we deposited today grew to 108 in 1 year, and then we added another 100, so that's the 208, right? So let's take that 208. Now we're going to make it a present value, because we're kind of shifting ourselves out to that 1 year period, and we're going to look 1 year out from there, which will be year 2 relative to today. I'm going to zero out the payment because I don't make a payment at the end of year 2. And I leave the 8%, I leave the 1 year in the N, that's already there. So now I'm just going to compute a future value. And lo and behold, yes, it comes out to be 224.64. So there is a way to do it on the calculator. It's a little clumsy, but hopefully you'll be able to start getting the hang of this pretty quickly. All right, so here's just some explanations. I already gave you the explanation, but if you want to read it, it's right here for you. All right, let's go on to the next example. Here, we think we're going to be able to deposit $4,000 at the end of each year for the next 3 years in a bank account that pays 8%. We currently have $7,000 in the account. How much will you have in 3 years? And then second question, how much will you have in 4 years if you leave all that money in there? Boy, this really does require a timeline. So let's put that out here first. And so we have 0, 1, 2, 3, and 4. All right. So we're going to start with, we have 7,000 in the account now. We're going to put 4,000 in each year at the end of the year for 3 years. Okay? Then we want to know, what do we have here and what will we have here if we leave all of that money in the account? Multiple ways I could go about this. I'm going to show you how to do this on the calculator. If you want to see how to do it by hand, certainly just follow through with the slide here. But let me show you how to do this and how I would go about this on the calculator. Because in the calculator, this becomes very simple. All right, so what I'm looking at here is I see that I have a value that's in the account right now. And so I'm going to view that as a present value. I also note that each of these additional payments in the next 3 years, they're at the exact same amount. And as we're going to find out later in the chapter, that's actually called an annuity. And the calculator does annuities for us very simply. There's that PMT key. It's a payment key. So if the payments are the same, I can simply use that payment key. Now, just a note, kind of a sidebar here, we are going to be able to deal with different cash flows in the future. It's a little more complicated on the calculator, but I'll get you through that as well. Okay, so here we are at the calculator. Forgive the emulator app here. For some reason, it keeps shifting its scaling around a little bit. I don't think it's it's probably not been updated recently by the developer. So sometimes it spreads the keys out. Other times it crowds them. I haven't figured out exactly what drives that. But by the way, if you happen to know, please leave a comment down in the comment section here so that I can fix this. But it'll still work. All right, so we've got 7,000 as PV. And by the way, first let's clear our work and now clear everything else. So we'll start with 7,000. And we're investing this, so I'm going to put a negative sign on that. And that's our PV. Now we have 3 more years where we're going to be depositing $4,000 per year. So let's put in 4,000. And again, that's a cash outflow, so negative sign. I'm going to make that my payment. And remember, this payment key assumes that the way I have the calculator set, and yours will be set that way too if you left it from chapter 5, is that payments always occur at the end of the period. So the very first payment is at the end of year 1. The second payment is at the end of year 2, and the third payment will be at the end of year 3. And so that reminds me we need to put in the number of years, and so that's a 3. Then we also want to put in our interest rate, which in this case is 8% right up here, right? So let's go back to the calculator, and we're going to put in 8% per annum. All right, now we're going to calculate a future value. Now this future value that we get is going to be the value right here at the end of year 3. So it's going to account for the $7,000 that we already have in the account, plus 3 additional payments of $4,000 each. And then we'll calculate that plus the interest, the compounded interest, at the end of year 3. Once we have that, then we will take it out one more year to the end of year 4, and we'll have the answer to our questions here. All right, so back to the calculator, compute, the CPT key, and future value. And I get $21,803.58, $21,803.58. And yeah, look, lo and behold, it's exactly the answer you get if you follow the method that they've outlined here as well. And like I said, I'm not going to walk you through that. It's pretty self-explanatory. If you'd rather do it that way, that works. Takes a little more time, but it works. Now, just one last thing we need to do is to move this payment out one more year to the end of year 4. And to do that, I'm going to take that future value and I'm going to make it a present value now, just by typing the PV key, leaving the amount there, hitting the PV key, automatically does it. One other thing I need to do is to make sure I zero out my payment key because I'm not making any additional contributions to this account. All I'm doing is leaving what's in there with the interest in there for one more year. So I'm getting interest only on that principal plus the compounded interest. And then I'm going to change this to 1 year for my N. So I'm moving one more year from beyond year 3 to year 4. And I'll leave the interest rate at 8%. And I'm going to hit the compute key and future value. And I get 23,546.87. And let's check, 23,547.87 cents right there. So you can do it either way. On the exam, you're going to have access to a calculator, obviously, a financial calculator. So you'll be able to do it that way, and that's fairly quick. I would still recommend, though, that you lay this out as an aid to make sure that you're accounting for all the cash flows and make sure that you're accounting for each cash flow at the correct time. These timelines are invaluable. This just is showing you we talked already about 2 different ways to do things. You can take each cash flow and throughout the time, or you can take period by period and account for all of the cash flows. This one is that latter method, period by period, accounting for all of the cash flows. And then here's an example of taking each cash flow and looking at it over the entire span of time. You're adding these together to come up with the amount. Likewise here, we're actually kind of keeping a rolling tally of the total amount. First we put in 2001 year. It earns our, what do we have? What are we earning? 10%? Yep. So it becomes 2,200 plus the next 2,000 is 4,200. Grow that for a year. That becomes 4,620. Add another 2, etc. You get the idea. It's just an iterative process. But the key point here is that no matter how you do it, this way or this way, you're going to end at the same answer, $12,210.20. All right, so another thing that I'll show you here is, let's do this in the calculator. So we have $2,000 that we're investing at the end of each period for 5 years. We have a interest rate or a yield on this investment of 10%, and we would like to know what it's worth at the end of 5 years. All right. So on the calculator, this is really quite easy. Again, let's second and clear our work, and then clear just the current work. And we're going to go 5 for our N. We're putting in 10% for our return. And we have 0 for PV because we're starting with nothing in it. We don't put anything in the account until the end of year 1. And so that's just the payment key. And we're putting $2,000 in at the end of each year. We've already got the 5 periods in there. All we have to do is compute our future value, and there we have it, 12,210. Actually, and I apologize, I should have written this 2,000 payment as a cash outflow, a negative, and that would make the return of our capital a positive, or a cash inflow of $12,210. And yes, indeed, that is exactly the answer that is shown here on the slide. So, all right, those are done. Now, suppose that we're going to be looking at present value. Suppose that we need $1,000 in 1 year, and then we need an additional $2,000 in 2 years. So again, timelines, very important. Here's time 0, here's time 1, here's time 2. We would like to have $1,000 here, and we would like to have $2,000 here. And the question here is, how much do we have to put in an account that earns 9% annually, compounded annually, to have both of those payouts over the course of our investment here? So the present value of $2,000 in 2 years at 9% is simply 2,000 divided by, remember here, because we're moving it back, we're discounting it, so we're dividing by 1 plus r raised to the t. And 1 plus r being 9%, there's our r, and then t being 2 years. So the value of that cash flow is $1,683.36. That's how much we would need to deposit today in order to have $2,000 in 2 years, if we put that into an account that earned 9%. All right. Now, what about the 1,000? Well, that's $1,000 divided by 1 plus r again, and t, of course, is 1, so we just ignore that. And that means that we're going to need $917.43 in order to have a sufficient amount of money in the account at the end of 1 year. So now all we're doing is we're taking those two present values, we're adding them together. So if we put $2,600.79 into our account today, in 1 year we'd be able to withdraw $1,000, and then in 2 years we'd be able to withdraw the final $2,000. Notice that we're only depositing $2,600, so that extra $400 is the interest that we're earning on this initial deposit here. To do this in a calculator, there's no direct route that we could get to. I could kind of give you a shoehorn route, the way that I would probably do it, and this may not make a lot of sense to you, but let me show you what I'm thinking. I'm going to put a different timeline down here. I know that the calculator is going to be able to deal with payments that are the same, and it can deal with a future value. So I noticed that here, if this first $1,000, I could look at the second payout as $1,000 plus $1,000. So let me get out of the way here. All right. So this amount and this amount would be considered a payment. And then this last $1,000 could be considered the future value. I know, maybe a bit weird, but this is how I would go about it if I had this particular problem. Let's clear everything out of here. And let's go with 2 years, right? And we're earning 9%. And present value is what we're looking for. We want $1,000 in our payment, and I'm going to make that a negative because that's an outflow. And I want another $1,000. Oh, sorry. Actually, that's incorrect. It's it's an inflow that we're looking at. All right. And then I want another $1,000, which is also an inflow, as my future value. Now all I do is compute a present value, and lo and behold, yes, I get that same exact amount, $2,600.79. Like I said, that may be a little advanced for you. And my director just walked in. You hear the clip-clop of her nails. She says, yeah, don't do that. Actually, another way to do it, this is kind of a preview of something we're going to be working with in the very near future in this chapter still. And that is, let's try using uneven cash flows. So there we can directly enter the 1,000 and we can directly enter the 2,000 and see how we hopefully we'll get the $2,679 present value. So first, again, I'm going to clear my work and I'm going to clear the current registers. And now I'm going to be using the keys in the second row. In particular, I'm going to be looking at the second column, second row, that's the CF key, and I'm going to be looking at the NPV key. Those are the two that are going to be relevant for me in this situation. So first thing to do, this records cash flows beginning with an initial cash flow at time 0 at today. In our situation, we don't have an initial cash flow. We want to know what that present value is, but we're going to leave this as 0 for the moment. Now we use the in the top row. If you look in column 3 and 4, we have an up arrow and a down arrow. We're going to be using the arrow keys. In particular, we're going to be using the down arrow now. And notice when I hit it once, I get C01. That means the cash flow at the end of period 1. Right? And that is $1,000. And one deviation here from the 5 keys that we've been working with, whenever I enter an amount, I'm going to have to hit the enter key, which is in the top row, second column. So I'm going to tap enter and notice that it put an equal sign up here on the left and added decimals to the right on the amount. So I know that it's in there. I'm going to hit the down arrow one more time, and I get this weird thing, F01. Well, what F01 says, or basically what it allows me to do, if I want to replicate that cash flow for more than 1 year, I can make that value different than 1. So if I want that same $1,000 cash flow for the next year as well, I could make this F01 a 2. I could put the value of 2 in there and hit enter. I don't want that. I just want the $1,000 for this 1 period. So I'm going to leave it as 1. It defaults to 1 anyway. All right. Now down arrow again. Now notice that changes to C02. That's my second year cash flow. It's the end of the period. And I'm going to enter that as $2,000. And I'm going to hit the enter key. And notice it makes that same change. And then down arrow and frequency again is 1. I'll hit the down arrow one more time just to see if my registers are clear. And sure enough, it looks like I did successfully clear the register. There is no cash flow in year 3. So we're good there. We'll go back up to year 2. Now, I want to know what the present value is. And I'm going to use this NPV key. Even though it's not PV, it actually serves multiple purposes. That's why they call it NPV, because it can do either a present value or a net present value. If we were to have put a value in the C zero entry back here. Let me go back. Oops. The CF0, cash flow 0. Had we put a value in there, it would actually be giving us an NPV as opposed to a PV, but we're just after a PV. So we hit NPV, and now I've got this I equals. Well, that's the interest rate. We're talking about 9% here, so I put 9, and I still have to hit the enter key. Don't forget that enter key. It'll mess you up every time. But whenever we're dealing with uneven cash flows, the way this calculator is set up is you've got to hit the enter key. Okay, so I've got that. Now I use the down arrow, and I see this NPV, but it says equals 0. It didn't do what I was hoping, and that is because I still need to do one more keystroke, and that is I need to hit the CPT key in the far upper left. When I hit that, you'll notice that I get my $2,600.79. So, multiple ways, even using the calculator, we can do this in multiple ways. So, back to the slides. Let's go on to slide 10. All right, so here we are looking at present value for multiple cash flows. And in this case, we have 5 different cash flows of $1,000 each. So again, this is very much like an annuity. In fact, it is an annuity. And here, one method to do this is to simply deal with each cash flow individually, move it all the way back 2 times 0, and then add up the amounts. So if we take this $1,000 5 years out, that has at, let's see, we're looking at 6%, I believe this is. So when we do that, the value of that is $747.26. Obviously, the closer cash flows are worth more, $890, $943, $40, and so on. Let me blow that up so that you can see those a little more clearly. So note, as the cash flow moves further away from us, right, in this direction, the present value of that cash flow declines. Right? If we had a cash flow of $1,000 at year 6, it would be less than $747.26. Right? I'm not going to go to the alternative slide. It shows you how to do it using all of the cash flows and go period by period. You can click on this little link down at the bottom if you'd like to take a look at that. So you can click on this or just simply go to the next slide, and it will show us an alternative method, which is to start at the far right, start out here at year 5, and take that $1,000 there, move it back, discount it back 1 year, so it's $943, add to it the next cash flow, so we have $1943.40, and then we move that back 1 more year, and that gives us $1833.39. We add to it the additional 1,000, we get $2833.39, and so forth. You get the general idea. I think this is probably repetitive enough that hopefully by now you are seeing kind of how things function. All right. So here, let me just add in the operators here. For some reason, iPad leaves those off when you use formulas, but these are all equal signs, so that's easy. All right, so here's an example where we're offered $200 in 1 year, $400 in another year, $600 in the next, and $800 at the end of the 4th year. We're using a 12% rate. This is an investment that should yield 12%. So the question being asked here is, if you were to be offered these 4 cash flows, what's the most that you would be willing to pay if the discount rate is 12%? In other words, if the riskiness of receiving these cash flows is equivalent to a 12% investment. All right, so here they're showing you how to do it by taking each cash flow and discounting it back the appropriate period, a number of periods. So here the first 200 is 1 year out, so we just discount it by 1 year, and that gives us $178.57. The next one is $400, and that's 2 years out, and we discount it down to $318.88, so forth. And then at the bottom here, we add all of these up, and we get a total of $1432.93. So as long as this $1432.93 is the same as the price that you were offered, then this is a good investment. The way of looking at this from a calculator perspective, we could do it this way, which is to say we do each payment separately. Okay, so now let's go to the calculator. And what I'm going to do is I'm going to clear the work and clear the current registry. I'm going to take 1 as my first cash flow, is 1 year out. My discount rate is 12%. The payment, there are no payments, so I want to zero that out. Even though I've cleared it, I always put a 0 in just in case. And it's $200 future value. And we're looking for the present value, so CPT and then PV. And we get 178.57, which is exactly what we're being shown right here, 178.57. We could keep going down that road, and we could then enter 400 as the future value, 2 is the number of years, compute PV, and we would get this 318.88 as well. All right, that's one way of doing it. A better way of doing it, or quicker way of doing it with the calculator, is to once again use our uneven cash flow keys here. I'm going to clear the work, clear the current registries. Now we'll use this cash flow key in the second row, CF. We're going to leave the times 0 cash flow at 0. We're going to use the down arrow in the top row and move to the first cash flow, which is 1 year out, or 1 period out. And I don't know why that didn't get cleared out when I cleared the work, but let me hit that again. And let's go down arrow. Okay, so that first cash flow is $200. And I'm going to hit enter, down arrow. And I can skip right past this because I just want that $200 for 1 year. Now I go to the second year cash flow, or second period cash flow, that's 400. And I hit enter, and I hit the down arrow twice to skip over the frequency. Third cash flow is 600, and I hit enter and down arrow twice. And then finally 800 for that last cash flow, enter, and I'm done entering my cash flows. Now I can go to my NPV key, hit the NPV key. It's going to ask me for the discount rate, and that is 12%. I'm going to hit enter again on that one, and then down arrow to get to the NPV. And now I still have to, just like we did last time, hit the compute button, the CPT button. And there we go, 1432.93 is the value of that cash flow. And if we go back here, there's our 1432.93. So yes, indeed, that did work. So practice these things. You know, stop the video, get your calculator out, go through this same series of steps, and if you get the wrong answer, go back and look at the video again. That's really the best way to get this down so that you can do this repeatedly and easily, especially when it comes time for the midterm exam or anything else. I mean, these techniques are going to be a large part of what you do in finance, whether you're working inside a corporation, whether you're working for an investment bank, whether you work for a commercial bank. Time value of money is a large part of what we do. And at the bottom of, at the end of the day, it really is this easy. It really is quite simple. It's moving money from one point in time to another, either by discounting if we're moving back to today or by compounding if we're moving out into the future. All right. So here we are offered an investment that will make 3 $5,000 payments. The first one occurs 4 years out, the second one 5 years, and the third is 6 years out. We have a rate of return of 11%. And we want to know what is the most this investment is worth today if we were to buy it today. So let's look at this timeline here, because this one is a little unusual. So we have time 0 and we have time 6. And if we do this as 3 in the middle, 1 and 2 and 4 and 5. Okay, so these cash flows are actually occurring out here. But there's nothing in these interim periods. So how are we going to handle that? And again, there are various ways of dealing with that. The one that I'm going to recommend that you use is to use the calculator. And even on the calculator, there are multiple ways we can do this. One is we can use the uneven cash flows. I don't think that's necessary here because the 3 cash flows that we're dealing with here, those are all $5,000. So there is a little bit of a shortcut, if you will, where we don't need to use the uneven cash flows. I'm going to clear our work, clear the registry. Now, so I'm just going to use the keys in the third row, the N, I, PV, PMT, and FV keys. So the way we're going to do that is we can think of this as a 3-year annuity that doesn't occur until some point in the future. All right, so we're going to be using that payment key for that annuity. So let's just put in the $5,000 for the payment. We're going to have a 0 in the FV. That should have been cleared anyway, but just in case. We know that the rate is 11%. So we're going to put that in as our I. Now, if this were an annuity that was $5,000 1 year from now, another 5 2 years, another 5 3 years, all we would have to do is to put in an N of 3, compute, and we're done. Here we can do that, but that's going to give us the value, not today, but it's going to give us the value right here at the end of year 3. So in other words, we're moving this 5K back 1 year. We're moving this 5K back 2 years. We're moving this 5K back 1, 2, 3 years. Now they're all lined up, but they're out here, and we really want them back here today. So let's do that first step. Let's get them all lined up at the end of year 3, and then we can very easily move them all the way back to year 0, or today, in other words. So there's our rate. We're going to do 3 as our periods, and we compute the present value. All right. Now, we've got this 12,218.57. So that's 12,218, 57. Now we can forget about all of this out here. Let's just erase that. Oh, shoot, disappeared. Let's just erase this bit. Out here, we don't want that getting in our way. Now we're dealing with simply a lump sum, right? Now we just want to move this lump sum back 1, 2, 3 years. We're still going to use the 11% rate to move it back. So let's do that. So I'm just going to change the sign of that back to a positive. I'm going to make that a future value. I'm going to zero out our payment, and then I'm going to leave in the 11% for I. And actually, in this case, we're moving back another 3 years. So N is 3. Now I'm computing my PV, and I get 89.34 and 12 cents. 89.34 and 12 cents. So that's 89.34.12. That's what those 3 cash flows in years 4, 5, and 6 of $5,000 each would be worth today if they had a risk equivalent to a discount of 11%. All right? So again, kind of repetition. This is sort of, hopefully you see that this is getting a bit repetitive, but that's a good thing because it helps to do these over and over until you can do it without even thinking about it. But you can also hopefully see the value of these timelines. I use these all the time to try to figure it out, especially if I have complex series of cash flows that I'm trying to figure out. When do these occur? When do I need to discount them? In some cases, in some of your future work, you're going to find that the discount rates are going to be different for a particular cash flow. If a cash flow has lower risk, we're going to discount it at a different rate than cash flows that have higher risks. So, repetition is a good thing. All right. Here, they're just showing us a different way of doing this. Still get the same answer. And again, I'm not going to go over this. I'll let you read through this and work through it yourselves. All right. In many situations, multiple cash flows will all be the same amount. In an annuity, it's a level stream of cash flows, just like what we looked at in the previous example. So in this case, let's suppose that an asset is promised to pay $500 at the end of each of the next 3 years. The cash flows from this asset form a 3-year $500 annuity. All right, just like the last one formed a 3-year $5,000 annuity. But this one is $500. The riskiness of this is equivalent to a return of 10%. So that's what we're going to use to discount. And let's go ahead and do this on the calculator. 500, that's going to be our payment. I'm going to zero out the future value. We had, what do we have here? 10% for a discount rate. All right, so let's do 10%. 3 years, compute PV, 1243.43. Yep, looks good. You're getting the idea. All right, so if we wanted a formula of some sort to actually calculate the present value of these annuities, say you didn't have your calculator, or you didn't want to do, 15 or so payments, you could easily do this with this this formula right here. So the C, of course, is the cash flow or the cash. R, in both these cases, is the discount rate or the return, the expected return, and then T is the number of periods where we're receiving this annuity. So you can calculate the present value factor. That's this portion of the annuity present value. And in this particular example, if we have 10% for 3 years, the present value factor is 0.751315. We would divide that by R. There's our R. The present one minus the present value factor is 0.248685 divided by 0.1 gives us 2.48685, and then we use that factor to multiply it by the amount of the cash flow. And again, here's that very same answer. So any direction you want to do it, that's fine. By the way, I should note that for the midterm and for the final, you will have a formula sheet. It'll include all of the formulas that are numbered in the text, And I consider adding other formulas too, as if you find that you might need them, just let me know. I'm happy to add those to the formula sheet. They do talk about an annuity table. It's much like the present value or the future value tables. Pretty much a thing of the last century with calculators and spreadsheets today. These tables are an anachronism. So, I mean, if they work for you, that's fine. But for the most part, I suspect they won't be very helpful to you. I'm not going to focus on those at all. Now, to find an annuity present value with the financial calculator, we've already gone through this, but you can walk through this slide again, just with with the same numbers we've been working with as an example, and practice that a little bit. Here's a bit of a different question when it comes to this. And instead of figuring out what the present value is, maybe we'd like to know what sort of car we might be able to buy if we know that we can spend X dollars per month and we're going to get a loan on that. So, and in this case, in this example, the X dollars is 632. We also are told that we're going to be using a rate of 1% per month. That would be 12% per annum. And the term of the loan is 48 months. So the question is how much can we borrow on this basis? Now, don't get me wrong. When the used car salesman or a new car salesman comes to you and says, tell me what you can afford and I'll get you into it. Don't fall for that nonsense. This is not that. This is you sitting down with your budget and figuring out what it is that you can afford. Many times car salesmen will attempt to manipulate the loan and maybe give you a 8-year loan in order to get you into a particular vehicle. That's not a good idea. So don't take this question as being something like that. This is just you sitting down with your budget and a calculator trying to figure out, well, how much could I spend on a car? All right, so we could use the formula here. So we could plug into this annuity PV factor formula. We've got 1% for 48 months. And then here again is our R. And actually that should be 0.01. There's an error here. This should actually be like that. And the same thing down here. All right. The end result is correct though, at 37.974. So this is the annuity present value factor. And so when we take our annuity payment of 632 times that factor, it tells us that we could borrow up to $24,000 to buy that car. Right? Now, how would we do this on the calculator? Let me show you that. And so I'm going to clear the registers out. And so we have $632 as our payment. I'm going to zero out the future value. And we're talking about 1% per month, 48 months. All right, now we're going to compute a present value. So $23,999.54 actually. But of course that rounds to about 24,000. All right? Good. Now let's keep moving on here. So suppose that you want to start up a business, and we know that that business is going to require $100,000, and we also would like to pay it off fairly quickly because, you know, frozen yak milk is not one of those things that's going to be a fad for very long. So we want to pay off the loan in 5 equal annual payments. The interest rate on the loan that we got was 18%. How are we going to do that? So again, we're going to use this annuity present value. Our loan is $100,000. We're looking for how much that payment is. We can calculate the present value factor. That's 1 over 1.18 for 5 years. And again, this is dividing by that R. When we get down here, we find that the 5 payments are each going to be $31,977.78. Again, how would I do that on the calculator? So we have $100,000 that we want to borrow. That's our PV. And we're going to zero FV just in case. We have 18% per year. We're assuming a annual compounding, so that's going to be 5 years. And now we're going to compute a payment. And lo and behold, yes, we still get that $31,977. So very good. Practice that. Here's a slide showing you that same process I just went through. Now, how about number of payments? We've been looking at the payment itself, what that's going to be, or what the amount we could borrow based upon a particular payment. But how about number of payments? In this case, we have used a credit card to borrow $1,000. By the way, this is a horrible idea, because what you're going to find out is that this takes a long time to pay off when you're paying the bare minimum, the minimum payment on a credit card. You are going to pay a huge amount of interest. Never, ever, ever do this. Only in the most desperate of situations should you even consider doing this. And you'll see exactly why in just a second when we look at the total time it takes. All right, so we borrowed the $1,000. We're only going to pay back $20 per month. The rate is 18% annually, but in the case of the credit card, they're compounding monthly, so it's 1.5% monthly. How long will it take to pay off $1,000? All right, well, we can get our present value factor here, 4, and we can plug that in and solve for a t up here. Actually, we're just doing it by trial and error basis. And we come up with a t of 93 months. That is 7 3/4 years. 7 3/4 years to pay off $1,000. The amount of interest that you pay on that is just mind-numbing. In fact, we'll calculate that in just a minute. Let me show you how to do this, though, on the calculator and clear out our registers. Okay, so we have $1,000 that we borrowed today. Zero out my FV, and we're going to make $20 payments. Make sure that the sign is the opposite of whatever you put in for the PV. I put in a positive 1,000, so I'm going to pay 20. That's an outflow, so it's negative. That's our payment. We're talking about a 1.5% monthly rate, and now we're going to compute N. That's our 93.1 months, and of course we just simply divide that by 12, and that will give us our number of years. A little over 7 3/4 years, 7.76 years to pay that sucker off. Now, another thing we could do is if we are paying out $20 for 93 periods, it comes up to a total of $1,860 of payments that we're making. We are paying almost the amount that we borrowed in interest simply because we're making a minimum payment on this card and the rate is so high. And when you look at cards today, 18 is actually relatively low, right? You see many rates well into the 20s. So this gets exponentially worse when we look at higher rates. It takes even longer and the amount of interest that you pay is really just usurious. No other words for it. All right. Here's the example that they show you how to do this in the calculator. So go ahead and practice that. All right. How about finding a rate? So we found a payment, and we've used the payment to find the borrowing potential. We're finding the length of time. And now how about figuring out a rate? So an insurance company offers to pay us $1,000 per year for 10 years if we'll pay the insurance company $6,710 today. Now, this is a fixed annuity, and there are a variety of these sorts of things around. Oftentimes they're done when you're retiring and you want to create some sort of stable cash flows. They're not a bad device. An annuity isn't bad as long as you're not paying any fees. And typically the average annuity, you're going to be paying fees, and they're going to be high. Avoid an annuity. If you see fees, either upfront fees, which are called front-end fees or loads, or if you see any sort of additional fees on the way out. There are a few firms that don't charge fees. In fact, I was just talking to a representative at TIAA. That's the Teachers Income and Annuity Association. Very large organization that manages retirement portfolios for anyone who is a teacher. So I have a portfolio there. Even if you're in grade school teaching or high school, usually they'll use TIAA. It's a very good company, great reputation. They have some of their own inside instruments that you can invest in, and they offer others like Vanguard and Fidelity and things of that nature. But nevertheless, they have an annuity that has no fees on it. So that makes these things a useful device. But the moment you hear an insurance person or an insurance salesman say something like, "Well, I can get you into this great fixed rate annuity," your warning signs ought to be going off in your head. What's he going to make off of this? So be careful. All right. So in this situation, we're trying to figure out what rate of return are we getting out of this for our money. We're putting in $6,700 and we're getting $10,000 out over the course of 10 years. All right, so here's the formulas if you wanted to do it that way, but let me show you how we would do it in the calculator. So we have $6,710, and that's going to be a payment that we make today, so that's PV. We have $1,000, and that's what's coming into us. I'm going to zero out the FV, and we're going to make that a 10-year situation, and now we're going to compute the I, and I get right at 8%. So that's actually, if you got something at 8% today, you'd actually be doing quite well. That's not a bad deal. Okay, so down here is the answer, 8%. And again, here they're just going into another example. Suppose a relative wants to borrow $3,000. She offers to repay $1,000 every year for 4 years. What rate of return are you getting out of that? Again, I'll leave it to you to read over the steps here, but let me take you to the calculator and let's see how quickly you can do it on the calculator. So we get $3,000 that we're lending, so that's an outflow, and they're going to pay us back $1,000. It's we're going to use the payment key for that. I'm going to zero the FV, and that is for 4 years, and I compute I, and I get a 12.59% interest rate on that, and that's That's about what they get there too. Here they have to because the math gets intractable. They're just doing trial and error to get the answer. And then here again is the information to do this on the calculator. All right, I am going to stop this video right here. We're going to pick up on future value for annuities in the next video, and we'll keep going on that. Once again, let me just reiterate, if you have any questions, if you have any problems with this material, it's not you, it's the material, and I'm here to help you. So make sure that you reach out either via email or call or drop by office hours. Happy to try to work with you, give you some more examples, that sort of thing. All right, good night.